You're listening to The Weather Junkies.
Oh boy. Large wedge tornado coming up into Tuscaloosa.
A winter storm warning is in effect for our area.
So we can expect at least another 2 to 4 inches overnight. Then that snow.
The National Weather Service in Huntsville has issued a tornado warning for northwestern Massachusetts.
14 to 22 inches of snow!
Welcome to this episode of The Weather Junkies. We're happy to have you here. We have an action-packed episode with Stu Ostro of the Weather Channel. I'm Tyler Jankowski, joining the show from the Champlain Valley alongside Dakota Smith, who is out west in Colorado. Dakota? Dakota is there now. Yes, Dakota, you're joining the show from Colorado. And he appears to be having some sort of
Can
audio.
you hear me now?
Yes, I can hear you now. It sounds like a cellular provider commercial here.
Oh my gosh. I tell you what, I'm done with this. Google Hangouts.
Are you joining us from your house or a restaurant?
Is it that loud?
No. No.
Yeah, so I'm out in Colorado, as always. Beautiful, beautiful day. Got into I think it almost reached 80 out here. Sunny skies. But I'm actually in the middle of a move right now. So this will be my second move since we started the show. I'm moving a little north to the city of Loveland in Colorado.
Ooh.
Yeah. We didn't want to move, but the owner of the house that we were renting decided to sell the house. So we had to get out of there. And the town we used to live in, really, really tiny town. But and it only had like one restaurant, no grocery store, nothing. And now we're moving to a place with several restaurants, and it feels like New York City to us because we're used to the farm life at this point. Anyways, that's my life, and my actual mic isn't working right now. I think it got injured in the move, so hopefully next week we have the mic running. And because of that, we couldn't do Facebook Live tonight. So hopefully we get all that fixed by next week. Tyler, how's the weather in upstate New York?
It is. It's pretty nice. We had 2 80-degree days earlier this week on Monday and Tuesday. Gorgeous. Now we are looking at another warm-up for Easter weekend, but a few showers. But the grass is turning green. I'm so excited. I stepped out, and each day we make a little progress. So we're heading in the right direction.
Yeah. Spring is here. Summer is close.
It is college football spring scrimmage season.
Oh my gosh. That is not the first thing that comes to mind when I think about
Well,
spring.
That's the first thing that comes to mind to me when I step out and smell the fresh air.
Baseball is what I think about. I'm sure summer is more baseball to you.
It is. Sometimes I jump the gun and I get a little excited about, one or the other, but yes, it's been nice.
Yeah. You want to start the Twitter section here?
Yeah, the first tweet we have is from Ryan Maui, and he has a graphic. We don't get to show the eye candy, but I'll describe what he tweets. And he tweeted, now over 100 days into 2017, the lower 48 temperatures have been about plus 3 degrees Fahrenheit above average compared to the recent 30-year average, the Pacific Northwest being the only exception. On his map, it's a lot of red, most of the country. So I know March was sort of a slow month for the Northeast, a lot of snow, a lot of cold, but overall, the first 100 days above average.
Yeah, it's a really nice graphic, as always, from Ryan.
Certainly, the warm February helped with that average.
Yeah, and the Pacific Northwest is a cold spot compared to average. The only place, I guess. So yeah, moving on here to another tweet from the National Weather Service. You can follow them on Twitter at NWS. Their tweet says, forecast update, there is a 50% chance El Nino will develop by late summer/fall. There's been a lot of chatter on social media, and I'm sure just in everyday life and forecasting offices about El Nino and La Nina and what's going to happen. Tyler, talk about this tweet here that you picked.
Yeah, the National Weather Service put out a forecast update saying there is a 50% chance of El Nino developing by late summer and fall. It perked my interest for a couple of reasons. One being, obviously, a year ago, we had that crazy warm and snowless winter because of a strong El Nino. Certainly, the prognostication is not as clear when you have sort of an intermediate El Nino, but when you get to the upper reaches, the stronger El Ninos, it usually means a much warmer winter for the Northeast. That's not quite what they're predicting, I don't believe right now, but still it like I said, catches my interest, because if we do head down that path, it would be perhaps a second terrible winter in 3 years. Not forecasting that right now, but something we're watching. The other reason it caught my interest was I saw a lot of tweets a couple of weeks ago from Michael Lowry, and he was saying that the waters off of Peru were very warm, and if you know anything about the history of El Nino, it was those fishermen off of Peru that sort of discovered that these things can happen. But according to Michael, most of the recent El Ninos have developed in the west and then moved east, and he was speculating that maybe if this El Nino develops, it would be one of the first east to west El Ninos in quite some time.
Huh. Yeah, that was a really great thread that he put out there. One other thing that I noticed from this is that it usually means if there's a peak El Nino in the summer or sometime during the tropical season, usually means the tropical season is below average. It's normally what happens, and lo and behold, the Colorado State Tropical Outlook, they put out a seasonal extended range forecast, and it's just below average. They have.
Well, and that's a good point, and I'm always a big fan of understanding the big picture. Got that from Dr. Neese at Penn State, and the explanation behind that is simply you have warmer water in the Pacific. It's still cold as you head towards Alaska, at least relatively speaking. So when you warm up the equatorial Pacific, it creates a bigger difference. You go from really warm water to really cool water, and that bigger difference creates stronger wind shear, which is not conducive to tropical development. So that's the explanation there.
Yeah, I will never forget the reasoning behind that, because I believe it was a question on one of our synoptic exams, I think.
Well, it's great when you understand it, because you don't forget.
Yeah, precisely. So yeah, we'll probably bring up El Nino again in the near future, because it's always changing, and the National Weather Service is always updating their outlook. Moving on to the final tweet here. It's actually not a tweet. It is the page of the Philadelphia Phillies, the Major League Baseball team out of Philadelphia.
Oh, really?
Yeah. Did you not know that?
Well, you said Phillies. I mean, where else would they be?
Well, some people don't know baseball, so I figured I'd help them out. Anyways, they changed their their description on Twitter. And their description says, not the GM, not the manager, not the players, not a meteorologist, just the official Twitter account of the Philadelphia Phillies. I thought that was really funny. I guess they must get a lot of mentions when it's like raining and there's a delay or something, asking whether or not the game's gonna go on or start back up or be canceled. Funny thing about that is meteorologists don't actually make that decision. It's the umpires that make that decision. Meteorologists can. What's
terrible
that?
Idea. Terrible.
Oh,
idea.
it is terrible. Yeah, we've talked about it before, how bad of a system it is. Meteorologists can guide the stadium on kind of what to do with the fans and what kind of things to look out for, but the umps are the ones that make the decision. So anyways, it's funny that they put that in there. their Twitter account. I
Yeah, I
tweeted
mean,
it today.
it's always easy on social media to spot people who are in tune and those that are out of tune. And to me, it seems like the social media manager is very much in tune to what goes on, perhaps even in the meteorology community. So I really appreciate the bio. I mean, it's them recognizing what we always clamor about.
Yeah.
I mean, it doesn't fix the issue, but at least they,
Yeah, right. Not everyone's going to read that and be like,
Yeah.
oh, I guess I shouldn't complain about this to them. So yeah, we can move on to our main topic of the night. It'll take a big chunk of the show. We're lucky enough to be joined by Stu Ostro of the Weather Channel. He's currently the Senior Director of Weather Communications and a Senior Meteorologist at the Weather Channel. He's been there since 1989, celebrating over 25 years there. And he got a Bachelor of Science degree from our alma mater, Penn State. He's from New Jersey. And we had a really good chat with him, Tyler and I, a few weeks ago. Our schedule was jam-packed in March, so we already had it scheduled. But we're going to bring you that interview tonight, and we'll go ahead and start it now.
And now we move on to our main topic with our special guest tonight. Stu Ostro from the Weather Channel is joining us. Stu, welcome to the show.
Thank you. I appreciate the invitation to be on.
So we like to ask all of our guests, especially the meteorologists, how they got interested in studying the weather and how they became an actual meteorologist. So tell us a little bit about that and when your interest started in meteorology.
Well, as you know, a lot of meteorologists and weather geeks got an early start, that there was something that happened in their childhood which led to it. In my case, it was extremely early, as my parents, when they were still alive, and I hypothesized that it must have been a close bolt of lightning and loud crack and boom of thunder when I was an infant, because as far back as I can remember, I've been obsessed with the weather. As at an early age as they could remember at the time, I was always obsessed with the weather. And as soon as I was old enough to actually utter the words, I want to be a meteorologist, that's how early it was. It was due to a phobia of thunder and lightning that went beyond a normal childhood fear, thus probably stemming from that early close bolt of lightning. And that just continued through childhood. I was fascinated with what produced my fear. I knew that I wanted to do this my whole life, and I ended up doing it.
That's great. And so you started, after you graduated from Penn State, you started at AccuWeather, and then you shortly moved to the Weather Channel. The topic of tonight's show is all about how technology and weather has changed over the past few decades. So I'm curious, when you were first starting at AccuWeather and the Weather Channel, what kind of data was available, and how were you viewing that data?
Well, that even goes back before AccuWeather to 1976, when I started at Penn State. And back then, not only was that before social media and all the other modern weather technology, back then, even something called the internet was not anything that we could have dreamed of at the time. So all the people much younger than I am that might be inclined to take this easy access for granted, back then, unless you were either at an academic institution or at a professional meteorological setting, such as private company or the National Weather Service or the military, you did not have such easy access. In fact, I don't think there was any access at all to real-time access to data or models. And back then, in order to get it, I didn't have it in my dorm room, so I would have to go to the weather tower at Penn State and we would hover over a teletype machine for the hourly obs each hour, and during a snowstorm, we would be very excited about it. Churn out of the machine, we would look at the obs, and then we would wait till the next hour for those observations to come out. Models got off a facsimile machine, and the only model output that we had back then was the barotropic model. I think we had the LFM, an early version of the LFM, and that went out to, I think it was 48 hours, 36 or 48. And then what we considered long range was a 72-hour spectral model forecast, which only had 500 millibar height lines, and that was it.
Wow.
It was very exciting when we got that out to 84 hours. So compare that with what we have today, which is instantaneous data, high resolution models with just about every field imaginable coming out of it. When back then we were really flying blind compared to now, and that in turn required a heavy dose of analysis. Every good forecast starts with analysis, good analysis. That's true today, but we've become in many ways so dependent on the models, and the farther out you go in time as you get out into the longer range, of course, a current analysis, while it's still important, applies much less. In a short range, it still is very important, but we would start every day with a hand analysis of a surface map. And then when you're trying to extrapolate out to even a 3-day forecast, and all you have is a 500 millibar chart, then it really was like solving a puzzle and putting all the jigsaw puzzle together and connecting the dots.
So would you say that forecasting was harder back then, and was it more fun or less fun, or how would you describe the difference between forecasting now and forecasting then?
Fun, that's a good question. It's certainly, by any reasonable standard, has to be considered harder back then because we just had so little to go on, not only in terms of how far out the models went, but the accuracy or lack thereof. It was also, for very short range stuff, it was before the NexRad era. So not only didn't we have things like Gibson Ridge and all kinds of sophisticated radar imagery to look at, but we had, when I started at the Weather Channel, one of the duties of behind-the-scenes meteorologist was to dial up a radar, which you would have to do, wait for it to come out on a little piece of paper, and then provide it to the on-camera meteorologist to look at. So for short range, not only severe convective forecasting, but anything like that, that's all we had for radar data. Back at AccuWeather, I remember plotting the code on a map. So for a regional mosaic, it would come out like 1, 2, 1, 2, 1, 2. So there were only 6 levels of reflectivity, 1, 2, 3, 4, 5, 6. Like TRW minus would be a 1, TRW 2, TRW plus 3, plus 4, TRW X 5, and TRW XX, most intense, was 6. And back then I had, and to this day I still have for my license plate, TRW XX. Goes back to what we had to deal with radar, for radar data and imagery back then. Satellite, same thing, wait for it to come off a facsimile machine, nothing like the loops that we have now. I remember the first time I saw a radar loop, satellite loop, and saw how fluid the atmosphere actually was. That was so exciting that I still remember it. And now I'm feeling that kind of excitement all over again as we start getting rapid scan imagery from GOES 16, like of the severe convection, a couple evenings ago. So in every way, we have so much more available to us now that in that sense, it's easier. As to whether it's fun and what's not easy about it, still being able to be precise and accurate for really high impact weather events, from how many tornadoes there were going to be the other evening, much less exactly where and when, and same thing with the outbreak a week ago. And I guess this is going to air a little bit in the future, but for reference, I'm referring to the late February and early March outbreaks, to tropical cyclones. Even now, the challenges that we faced with Hermine, for example, with what it was going to do off the northeast coast last summer, and on from there. And in some ways, this is where it can be even more challenging, more difficult, is because the expectations are so much higher because of the increased accuracy, the reliability of computer model forecasts, the imagery, the data, everything that we have now, as well as the communication thereof with social media and everything that's out there and stuff that shouldn't be out there, that on a day-by-day basis, it isn't with just as many challenges as existed back then.
Yeah, so I want to talk about the communication aspect. Nowadays, as a meteorologist on TV, you can just display the data and then talk about the data. But back then, I'm assuming it was a little different. What were some of the ways that were different in communicating weather risk?
Well, in terms of weather risk, I guess I would put it purely in terms of communicating weather risk. I'd put it in terms of things like probability and how far out into the future the forecast is. Now we have graphical tools such as the tropical cyclone cone of uncertainty, other tools on television to communicate that uncertainty. Back then it was the same thing, just the tools were not as sophisticated. And that is one of the common themes and most important things about weather communication that was true then, and it's true now, and it isn't always successfully done, and it isn't always easy to do and do successfully, which is communicate the appropriate amount of uncertainty. So whether it was back then and you couldn't show as much data per se, or whether it's now and you can show that and you have different ways of communicating the uncertainty, there's still the matter of how much to communicate. If you don't communicate enough, then you're not being true to the science. If every forecast you're going out there and saying, well, we don't really know what's exactly going to happen, then you also reduce your credibility. So the key is finding the right balance in each situation. And the one thing I learned very early in my career, I still try to do to the best of my ability every day, whether it be a briefing that I'm giving at the Weather Channel, a casual conversation with them that I'm having with somebody there, or another user, or a family member, or an occasional cameo appearance on the air over the years, whatever the vehicle of communication is, it's emphasize what you're sure of and what you're not sure of. So, for example, with a snowfall or a tropical cyclone forecast, or severe convective forecast, or a longer range temperature prediction, you may be sure of the generalities. We know that the jet stream is going to take a dip. There's going to be a sharp trough. We expect a storm to develop somewhere along the northeast coast. What we're not sure of is the exact track from there, the intensity, how many inches are going to fall. The morning of a severe convective outbreak, may be very confident it's going to be a widespread outbreak. You know that there are going to be the ingredients for tornadoes. You're not sure the details of that outcome, but you can convey the relative level of risk as the Storm Prediction Center does for the situation. So just emphasize what you know and what you don't know. Try to strike the right balance and don't go too far in either direction. And it's very easy to slip off that cliff either way.
So your current title at the Weather Channel is Senior Director of Weather Communications and Senior Meteorologist. Take us through what you do on a daily basis nowadays.
So yeah, over the years, I've done a variety of things. I alluded to cameo appearances, got my feet wet early during the perfect storm, Hurricane Andrew, and the 93 superstorm. Nowadays, don't go on the air live very often, but I still do tape sound bites. For example, recently, and it'll continue to be repeated, show top 10 ultimate storms. I helped with the development of that list of storms and was interviewed on camera for it. The main thing I do on a day in, day out basis is I'm the lead briefer for what is called the morning editorial meeting, in which a whole bunch of people from different parts of the operation get together, from the news side, production side, as well as the meteorology side and everything in between. And also for the Woo TV, the Weather Underground show, I give the briefing for that. So a good chunk of my energy is spent analyzing the current and future situation and envisioning in my mind how to best boil it down for the recipients of that information who want the most important points, putting perspective on it. So not just the pure forecast, but if there's going to be this particular outcome, is that unusual? Is it extreme? Is it typical for this time of year? That sort of thing. I also, over the years, and to some extent, am still involved in providing input to the Weather Channel crew placement. One of the favorite things that I do nowadays, which is not what I would have expected, I went kicking and screaming into the Facebook world, and as it turns out, I'm glad I did. I ended up meeting my future wife that way, who's also a weather geek. But then Twitter, really capture the essence of a whole weather situation in 140 characters, when over the years it had frustrated me when I would give a soundbite and the folks filming it would say, well, that was a little too long. Can you maybe shorten it to 8 seconds? But actually, it turns out that you can communicate weather information effectively in 140 characters, especially with an image, when a picture is worth 1,000 words. And so I really like that part of it, boiling everything down and connecting with weather geeks like yourselves and so many others out there.
So earlier in our conversation, you talked about how little data you had. Now we have a ton of data. In your view, from your perspective, how do we sift through all of the different models we have nowadays and all the different data sources? What's the best way to do that? Because it's impossible to look at everything.
That is what when you asked the question earlier about what's fun about it and what's not fun, and how is it easier, how is it more difficult, and the amount of model information which is available is one of those things which is a double-edged sword. On the one hand, it sure makes our job so much easier to have all the model information we do, not only different models to look at, but the types of output, including specific severe convective parameters, algorithms that actually predict the amount of snow and ice, compared to when I started my career, when just figuring out the basics of the synoptic situation and what it was going to do, much less coming up with a snow QPF. Now it makes it a lot easier in that respect. But then the flip side of that are things such as the expectation that we can be very precise in a fall forecast, and with forecasts out there to the precision of an inch, which realistically is not possible. So that goes back to the certainty versus uncertainty. Precision is related to that. Another thing is just model fatigue, burnout, just being overwhelmed with so many models, so much information. And with that, it's just getting a feel for what models are best to look at in different situations, whether it be the longer range and the global models, and recognizing, particularly lately, how much, and it's not your imagination that at least the current versions of the ECMWF and the GFS, the GFS has had some really bad busts lately. And so knowing how to weigh the global models, looking at the whole range of them from the longer range to the short range, which ones to look at, how much to factor in. Ironically, given the issues of the GFS, and I know how controversial a topic that's been with the state of the US models, there's been a US model success story, which is the HRRR, which in its current generation is one of those things compared to when I started my career, I could not have imagined it. It's remarkably good. So knowing what's good about the models, but also knowing their limitations, that the HER is not going to handle as well, and even when it does handle them well, it's not going to be correct down to the pixel, and that's where they're with model output, which is shown on television, including the Weather Channel, where it looks so real that it almost, you stare at a model long enough and you think that it's reality, when in fact it isn't necessarily. So processing all that and then translating that into the communication that I was referring to. And then the other thing is really looking at the ensemble approach, which is another thing that was not available in my career, and knowing how to use them, factor that into your confidence level of what the outcome might be. Oh, and one more thing to mention is, and speaking of controversial topics, it's social media, the posts of model forecast, specific forecast images out 10 days, out 16 days, and having to deal with that. When that started, I had conversations with my colleagues, and there was lamenting of that. But my point of view from the start was, that's out there, that horse is out of the barn, and there's nothing that we're going to do to get it back in. So the best way is to just realize that and deal with it. And what we can do as individuals, as well as in our job with the Weather Channel and helping the network do it, is put the perspective on those forecasts. That if there's a model forecast out there showing a blizzard in New York City 10 days from now, okay, so rather than avoiding talking about it, let's talk about it. Let's talk about what the factors are that would go into that happening, and what the uncertainties are at this time frame.
So your days in the Campus Weather Service date back to the late 1970s, and your resume says that you participated in radio broadcasts. It's very exciting to see the Campus Weather Service flourishing to this day, and certainly harnessing the power of social media and also live broadcasting on platforms like YouTube. But back when you were doing radio in the late 1970s, tell us a little bit about that, some interesting facts that we may not know, and maybe we'll enhance our appreciation for the nation's largest and oldest student-run weather forecasting organization.
Well, that brings back memories. I can picture myself sitting there at the desk, picking up the phone, calling the radio station, and they would turn on the tape recorder, and I would give my forecast. and it involved the processes that I've been referring to with the very limited information that we had back then. So if it was a short-range forecast and there's an ongoing weather event, it would be waiting for those hourly observations to come across the teletype. So I had the latest data, had no real satellite information that was of value for a real-time forecast back then. I had a little bit of satellite imagery, but not much. Radar, not much, and all that limited model output. And you'd sit down there and pick up the phone and give the forecast, and that was it. I don't know exactly what process they're using today. I would imagine with radio, some of it is the same with giving an audio forecast to a radio station, but now as even a radio weather service broadens, and we've seen that, for example, even the Weather Channel has a radio component, TV component, social media component, so that goes into the whole realm of weather communication.
So when I think about technological advances and the Weather Channel being at its prime, it's during big weather events like Hurricane Matthew or like a big East Coast snowstorm, some things along those lines. So I'm curious, what are some of the things that you all might be hoping to do in the future during those big events to continue to enhance to what I think is the best coverage of big events?
Well, thank you for the positive feedback, and I guess this goes back to the same kind of thing as when I said the common thread, the same basic principle as has always existed in weather communication of a forecast, which is emphasize what you're sure of and what you're not sure of. With the Weather Channel storm coverage, you're right. It's something in which we can put everything together. We can really shine. It is an important part of what we do, not only as a business and a successful business, but as part of our mission of communicating important weather information and life-saving information as part of that. So it's everything that you see, forecasts, state-of-the-art graphics to help tell the story and visualize it, some of the augmented reality 3D kind of stuff, which we do on a daily basis. Then the expertise that we have of specialists in the respective seasonal forecasting realms, and the live coverage, which we've been doing for so long with Jim Cantori and everybody else in the field. Now also as part of that, so I mentioned Twitter and being able to communicate weather information through Twitter, can also get weather information that way. Now, a note about that, as I learned very early when I broke through my skepticism about being able to use that as a medium, an effective medium of communication. Don't believe everything that's out there on the internets and everything that's out there on Twitter, and likewise, think before you tweet, think before you retweet. But with that disclaimer having been stated, and that includes things such as doctored photos, or even recently there was a fake photo of a hailstone that was making the rounds again. But that all having been said, there's a lot of valuable information out there that can be disseminated quickly on social media. And in turn, as part of our storm coverage, some of the video and even some of the best video that we get in now is via social media. So it's a combination of all that and continuing to do that as best we can, and always looking for ways to continue to do it even better. It continues to evolve.
So speaking of social media, I've noticed that every now and then you manage to find a weather image, whether it's I think it's normally a satellite imagery of some sort, whether it's visible or infrared. And you tweet it out or share it on Facebook, and it goes absolutely viral, like not even weather viral, just like straight viral. An example of this is the skull-like image in infrared satellite imagery of Hurricane Matthew, which was creepy and cool and weird all in the same time. I'm really impressed by this, but I'm curious, how do you manage to find these nuggets so often?
Well, thanks. I'm glad you enjoy them, and that is one of my favorite parts of what I do. Not only communicating the weather information, but I always am looking for images that tell a story. Maybe, now that you asked the question, I never really thought about this, but maybe it's because of the limitation. Even in Facebook, you can do longer posts, but still, generally they're shorter. But particularly with Twitter, by being limited to 140 characters, I guess maybe that just led me to look for other ways to tell the story with more characters and words without actually using the characters and words. And as I said earlier, a picture is worth 1,000 words. That also, my father was a professional photographer, and I think I inherited his artistic interest. And so even though it's just with my cell phone camera, I also like taking weather photos myself. My wife Leah is an accomplished, award-winning weather photographer as a weather geek, and I am even on the way to the Weather Channel, sometimes I'll just see something in the sky and I'll pull over to the side of the road to be able to take a photo safely. And then with satellite and radar, it's that in terms of being able to tell a story without using any more words. It's just the weather, so it's a communication tool in that sense. It's also a communication tool by being able to tell a scientific story. It can be a forecast, it can be an overall scientific story showing the ingredients that go into it. It can be representing the power of the physical universe, which with weather, it's weather is the most direct and continuous connection we have with that, showing the incredible power of a hurricane on a satellite image, or signature on radar, which is fascinating, as well as providing life-saving information. And then as part of that, it's just geeking out and connecting with fellow weather geeks. The backstory behind the skull image was I gave one of those weather briefings, which I do every day. This one, of course, the room was packed because of what was going on and what potentially was going to happen with Matthew. And then after, we go around the room and folks from the other departments share their latest information. And one of the things is to present the latest video that we've gotten in, and I give the HDMI cable over so those folks can do it. And so my screen wasn't up on the projector, and I thought, let me just check on some of the latest data and imagery. And I pulled up that satellite loop from the NASA Earth Science Office website, and I go through it. I was like, whoa, what was that? Is that what I thought it was? And then I stepped through frame by frame, and I just, my jaw dropped. And then I was trying to decide, should I show it? Should I not show it? Yeah. So I took the HDMI cable back, I put up there, and everybody just went silent. I said, yep, that's actual image. And then it was just a natural next step to post it and tweet it. And I thought it might get more attention than usual, but little did I know that it would go that viral. It would, not only in terms of how many retweets, but websites, blogs, newspapers all over the world, literally. And little did I know I would find myself on Inside Edition talking about it the next day.
Wow.
So each person that comes on the podcast gets asked a familiar question at the conclusion of the podcast. And that is, Stu, what advice would you give to someone who's interested in studying meteorology and perhaps watching or listening to this podcast in high school, or to someone that's already in college studying meteorology? What would your advice be to them?
Couple of things. One, balance. Well, I would say both. Represent both your passion and reality, and balance them. And what I mean by that is absolutely follow your passion. At the same time, realize that for as long as I've been in the field, and it seems like more than ever now, there are more graduates in meteorology than there are jobs, so it is very competitive. What you can do in regard to that is, even if that weren't the case, what I would advise anybody, which is be as diverse as possible in your knowledge and skills. So that could be something as overt as minoring in something that would be a backup job opportunity, such as computers, computer programming, other things with computers. But even if not that would be something that would help you get a job in meteorology. And I know there's been stuff in the blogosphere about that recently, just the need for those sorts of technical skills, which weren't as necessary when I started my career. But then beyond that, really pay attention to other things aside from just purely meteorology, in particular communication skills. Being a good communicator, both with oral communication and written communication, will serve you well, even if it's not the core of your job, like it is for me with my briefings, like it is for meteorologists who are on camera and communicate in other ways as a fundamental core job responsibility. Just any kind of interaction you have in the workplace in which you can communicate as effectively as possible will help you. And then just basic stuff, whether you refer to it as leadership or basic work skills, strong work ethic, volunteering for things, taking ownership of things, leading projects, that sort of thing. Just being as complete a package as possible to with which to sell yourself, while at the same time enjoying science. And here's I guess we can end the way we started, which is the phenomenal difference in technology between when I started my career now and going back even before that to when I was an infant, then a toddler, then growing up, and eventually in college, and then in the workplace. Was back then, without all that access to weather information at your fingertips, you can't geek out like you can now. You can't be engaged with your passion in that sense. Whereas now, even if you don't end up, whether it be you get a degree in meteorology, you have a plan B, you end up going with a plan B, or you just decide, as many people do, that you're going to go down a different route, but you still love the weather, and now you can geek out to your heart's content with all the imagery, model, data, Twitter, blogs, everything in between, your podcast, everything. You can be connected to the weather in that way, and you can also learn so much about the weather. And no matter how long I've been forecasting, every weather event is a new challenge. You learn something new. And not only have I been fascinated and obsessed with the weather since I was in the crib, But the older I get, and I'm 58 years old now, and I am more obsessed and more fascinated with the weather than it's just so awesome. And now, no matter what profession you end up going into, you can connect with that every day.
From having a diverse skill set to enjoying yourself, that was definitely a complete bit of advice there. Stu, thanks so much for taking some time to join us tonight.
My pleasure, and thanks again for having me.
A wonderful interview there with Stu Ostro of the Weather Channel. We thank him for coming on the podcast, and we certainly hope you enjoyed the interview there. Dakota, any final thoughts about the discussion?
You know, I still struggle taking in what it was like as a forecaster, as a weather enthusiast, as a weather weenie, just 10, 20 years ago. It's changed so rapidly, and it continues to do so. I think one example, modern example, is GOES 16. People who are maybe just about to go to undergrad in the fall and major in meteorology are going to take that kind of imagery for granted, like we take dual pole radar images on our cell phone for granted. So I think it's amazing, and it was really, really interesting to hear his comments on that and where he thinks we're going to go in the future.
Who knows where we'll be in 10 years?
Seriously,
we didn't have Facebook Live 3 years ago, so we're moving fast.
Yeah, so it'll be interesting. But that's going to do it for us tonight. Thanks so much for sticking with us. It was a little bit of a long episode tonight, but we'll still be under the hour mark. If you don't follow us on Twitter, go ahead and follow us at the WX Junkies. We're also on Facebook. Give us a like there. And if you're listening to this podcast on iTunes or any podcast provider, go ahead and give us a rating or review. You'll get a shout out on the show. I have a few shout outs that I need to do in the next few weeks. So if you haven't got one yet, stay tuned for that in the next few episodes. Tyler, we have a pretty awesome schedule lined up here for the end of April. What can we expect?
We do. Next Thursday, April 20th, we have Andrew Green. He is the CEO of My Radar, which is a very popular radar app. So we're excited to have Andrew Green on next week to talk about his app and where they came from, where they're going, and what's behind what they do. And then after that, an episode that we're very excited about. April 27th, to close out April, we have Ginger Z of ABC News and Good Morning America, a big show planned for April 27th. That's the final Thursday of April. So the next 2 weeks are planned out, and we also have a number of ideas for May. So quite a slate going forward. And that'll do it for this week, though. We certainly hope you'll join us right back here next week on the Weather Junkies.